Hello everyone, I am Deepali Jadhav working as an assistant professor in Electronics and Telecommunication Engineering Department. Today we will see the practical implementation of amplitude modulation under the course analog communication. So before that, first of all, what is modulation? Modulation is nothing but changing the amplitude, frequency or phase of the carrier signal according with the instantaneous amplitude of the message signal. This is called as the modulation. So here in block diagram we can see that the modulator will have two inputs: baseband signal, that is the message signal, and high frequency carrier signal. So using these two signals, it will update the amplitude, frequency or phase of the baseband signal according to the type of modulation. Here amplitude modulation is shown. So before that, first of all, why we have to do the modulation in communication, or what are the advantages of using modulation in communication? So first and very important advantage is reduction in height of the antenna. Then second, it avoids the mixing of signals while transmission. And next, it increases the range of communication. Also allows us to use the multiplexing techniques in the transmission. Also improves the quality of signal in reception. So there are three types of modulation: AM, amplitude modulation, frequency modulation and phase modulation. As shown in the figure, you can see that first amplitude modulation is nothing but, in this case, amplitude of the carrier signal will vary according to the amplitude of input, that is baseband signal, and it is used in radio broadcasting for long distance AM radio. Also it was used in older analog TV systems. Then second, that is frequency modulation. In frequency modulation, frequency of the carrier will vary according to the amplitude of input signal, information signal. This can be used in FM radio broadcastings, two-way radios, and in some satellite communication systems also FM can be used. Third type is PM, that is pulse phase modulation, and in this, phase of the carrier signal will vary according to the input modulating signal. And this type of modulation is used in most of the satellite communication systems and also in some mobile communication systems. So next is, we will see the amplitude modulation in detail. Amplitude modulation is nothing but a technique in which amplitude of the carrier signal will vary with respect to modulating signal, and it keeps the frequency and phase of the carrier signal constant. As we know, the carrier signal is very high frequency signal as compared to the information signal. Generally, information signal will be considered as an audio or video signal, and this will be called as a baseband signal or modulating signal. Now these are the waveforms for amplitude modulation. First waveform shows that modulating signal or input analog signal, and second, carrier wave, which is very high frequency signal as compared to the modulating signal, and last, third waveform shows the modulated signal, AM modulated signal. In this case, we can observe that the amplitude of carrier signal is varying according to the amplitude of modulating signal. Then in detail, we can represent the AM signal in time domain like this, where maximum and minimum amplitudes are shown. Then with using of these maximum and minimum amplitudes, we can find the modulation index. So what is modulation index? It is nothing but the ratio of modulating signal amplitude and carrier signal amplitude, that is M is equal to EM divided by EC, and in percentage we can express it as a EM by EC into 100. And while calculating the modulation index in practical session, we can use the last formula, that is Vmax minus Vmin divided by Vmax plus Vmin. Then there are three types of modulations in AM according to the value of modulation index. Case 1 indicates modulation index M is less than 1, that is called as under modulation, where in the diagram it is shown as a 50% modulation AM wave, and in this type we can see that the no information will be lost as amplitude of the carrier signal is greater than the amplitude of modulating signal. Then second case, M is equal to 1. In that case, EC and EM both are equal. So this will be called as a 100% modulation and critical or perfect modulation. Then case number 3, that is M modulation index is greater than 1. This case is called as over modulation. In the diagram it is shown with 150% modulation. In this type of modulation, when we go for the demodulation, there will be loss of information. That's why this over modulation is not used in practical purpose. Now we will see the practical implementation of AM. Now we will see the practical implementation of AM modulation with this circuitry. So here this circuitry shows the AM modulation. This is the power supply pins, VCC plus VCC minus VCC, ground. There are two types of detectors on the circuit, simple diode detector and practical diode detector, and after that low pass filter can be used, and this is the signal generator. There are two different knobs, frequency knob and amplitude knob, to change the audio frequency and amplitude also. So we will see the connections. For that we have to connect this VCC pin, supply voltage, to the circuit VCC pin, then ground pin to the ground of circuit. Next we have to connect the audio signal as an input to the AM signal, AM circuitry. So this pin will be connected to the input and this pin will be connected to the ground pin. Now these are the connections for AM modulation. Now we will observe the waveforms, input and AM modulated output on the DSO simultaneously. So first of all, I am going to connect channel number 1. This ground pin will be connected to the ground and second pin will be connected to the input of modulating signal. Now second channel will be connected to the modulated output and ground pin will be connected. Now I will switch on the circuit. Now we can see first channel, that is yellow color waveform, shows the input waveform and second waveform shows the AM modulated signal. Here we can see that this case is under modulation. We can change the modulation with this knob. This is under modulation, this is critical modulation, and this is over modulation. Okay, we can observe this is over modulation. In over modulation, we will get the distortion or data will be lost. Now we can see the effect of amplitude of audio signal also. This is the amplitude effect and this is the effect of frequency. Now with the help of these waveforms we can find the modulation index also. For that we have to use the formula M is equal to Vmax minus Vmin divided by Vmax plus Vmin. For that, how to calculate or how to measure the Vmax? This peak to peak amplitude of this AM signal will be considered as a Vmax and this will be considered as Vmin. With the help of this we can calculate the modulation index and we can see the effect of modulation index on the AM signal also. This is over modulation. Thank you.